Hi everyone in Algebra 3. Today we're going to be going over your questions on lesson 66. We're going to start with number 1. The cost of the landfill varied linearly with the loads of dirt required. If 10 loads were used, the cost was $13.50. If 20 loads were used, the cost was $2,200. What would a landfill of only 5 loads cost? So for number 1, we have cost varied linearly with the loads of dirt. So it'd be C equals MN plus B, where C stands for the cost, N is the number of loads of dirt. And then it says 10 loads were used, the cost was $13.50. So the cost is $13.50, and that was the cost of 10 loads. So it'd be 10 plus B. My second equation is if 20 loads were used, the cost was $2,200. So that would be $2,200 equals M times 20 loads plus B. So those are both equations of a line, and now we're going to solve for the we're going to solve for M first. So I'm going to start by multiplying this top equation by -1 so I can eliminate B. So that'll be $13.50 equals -10M minus B. My bottom equation is going to be 2,200 equals 20M plus B. I'm going to use my calculator because it's Friday. So 2,200 minus 1,350, I get 850 equals 10M because the B's are going to cancel, which means that my M is going to be equal to 85. Now, once I solve for M, I'm going to use that to solve for B by plugging it into one of the equations. I'm going to plug it into the top equation because the numbers are smaller. So it'd be 1,350 equals 85 times 10 plus B. So we're going to subtract 850. So 1,350 minus 850 would give us 500. So that means B equals 500. So now we have this, the cost varying linearly with the number of loads of dirt would be, the equation would be C equals 85 times the number of loads plus 500. But then it says, what would a landfill of only 5 loads cost? So we're solving for cost when we know that there are 5 loads of dirt. So you're just going to do 85 times 5 and then add 500 to that. And you get the cost is going to be equal to $925. So moving forward, we're going to look at number 4. And I think number 5 as well. Yeah, 4 and 5. So for number 4, the wheels on Danny's Bobcat had a diameter of 26 inches. If he was traveling at 12 miles per hour, what was the angular velocity of the wheels in radians per minute? Okay, so for number 4, the equation that we know is linear velocity equals angular velocity multiplied by the radius. We're trying to solve for the angular velocity, so I'm going to multiply both sides by 1 over the radius, which means that my angular velocity is going to be equal to the linear velocity times 1 over the radius. And they give us all of this information. They give us that he was traveling at 12 miles per hour. So that means the velocity is going to be 12 miles per hour. And then the radius, the diameter is 26 inches, which means the radius is going to be 13 inches. And we need this in radians per minute. So I'm going to start by converting inches to miles. So I know that there are 12 inches in 1 foot. And then I know that there's 5,280 feet in 1 mile. My feet cancel and my miles cancel, and then hours to minutes would be 1 hour, 60 minutes. So notice that there's no longer a unit of measurement anymore. So all of my units are gone, and radian is the one that you can add in or take away as needed. So my answer is going to be 12 times 12 times 5,280 over 13 times 60. And I'm going to label that as radians per minute. Okay, and that concludes number 4. Then moving forward to number 5, we have Ralph traveled K miles in P hours and then traveled Z miles in P plus 6 hours. At the overall average rate, how long would it take Ralph to travel 740 miles? So, sorry, number 5, we have overall rate is equal to overall distance divided by overall time. So our overall distance, it's going to be K miles and then Z miles. So that would be K plus Z. Our overall time is going to be P plus 6. So that would give me K plus Z over 2P plus 6. So that's my overall rate. And then it says, how long would it take for Ralph to travel 740 miles? Well, if distance equals rate times time, my distance is going to be 740. And this is going to be my rate. So K plus Z over 2P plus 6 times time. So how do you get the time by itself? You would multiply both sides by the reciprocal of the K plus Z. So that means my time is going to be equal to 740 times 2P plus 6 over K plus Z. And for this one, they probably factored out the 2 and then multiplied it by the 740 as well, and left it as P plus 3 in parentheses. Either way would work. Now moving on, we're looking at number 6 on this lesson, number 6. So it says Mumbo traveled M miles at A miles per hour. Jumbo also traveled M miles, but at a faster rate of Z miles per hour. How much longer did it take Mumbo to make the trip? All right, so we have the distance of Mumbo is M miles, and the rate of Mumbo is A miles, which means that the time of Mumbo would be M over A. Now we have the distance of Jumbo is also M, and then we have the rate of Jumbo, which is Z, which means the time of Jumbo is M over Z. And it says, how much longer did it take Mumbo to make the trip? Because Mumbo's time is longer, so this one's longer, because he went faster. So that means you're going to subtract the smaller one from the longer one. So it'd be M over A minus M over Z. And then that would give me MZ minus AM over AZ. So they just wanted to know the difference between the two, and obviously you would have to determine which one's the longer one, so you can subtract the shorter one from the longer one. Okay, now looking at number 8. So for number 8, it says write the equation of problem 8 as a cosine function. So for number 8, which you'll notice, wow, whoopsies. Number 8, what you're going to notice is it's already a cosine function. It's actually a negative cosine function. So when you're doing this problem, we're going to say that we have a negative cosine function. So that's going to be y equals a minus b cosine c, and that's going to be x minus d. Well, we're not going to have a d because it's already a cosine function. It's already a negative cosine function. but we do need to solve for a, which is our midpoint between this top value and this bottom value. So we're going to do top plus bottom divided by 2. That would be -2 divided by 2, which is going to be -1. Then b is going to be the difference between the top and the middle point. So that would be top minus whatever I got for the middle, which was -1. So that would give me 8. Now C is the tricky part. So C is going to be 360 divided by the length of the period. So the period length, notice how it dips down and hits its lowest point at 0 degrees. Now I want to find out, where does it hit its lowest point again, at what degree? So if you go over to the right 0 degrees, it's going to hit its lowest point again at 180 degrees, which means the length of the period is 180 degrees. And 360 divided by 180 is 2. So now, for number 8, we have my A, my B, and my C. Again, we don't need D because it's already a cosine function. So this is going to be y is equal to -1 minus 8 cosine 2x. So again, there's no phase shift because it's already a cosine function. And that is your result for number 8. Now moving on, we're going to look at number 16. Number 16, we have x squared minus 8x plus y squared plus 6y equals -16. So what we're going to do first is we're going to put all the x's in parentheses and all the y's in parentheses. So x squared minus 8x, leave a space, plus y squared plus 6y, leave a space, equals -16. So now we're going to complete the square. So half of -8 would be -4. Half of 6 would be 3. But don't forget, when I square -4, I get plus 16. So I would have to add 16 to both sides. When I square 3, I get 9, and I'd have to add 9 to both sides, which means that I end up with this equation right here. X minus 4 squared plus y plus 3 squared equals 9, meaning that the coordinate for the center of my circle is going to be as given. It's the opposite of that, which would be +4, -3. And the radius of my circle is just going to be the square root of the right side. So you take the square root of 9, which gives us 3. So now I'm going to graph this. So 1, 2, 3, 4, so the coordinate for the center of the circle would be over 4 down 3, which would be right here. And in either direction, you're going to go 3 spaces. So up 3, to the right 3, to the left 1, 2, 3, and then down 1, 2, 3. And then you're going to connect the dots. And that's your radius, which is 3. And that's your result for number 16. So completing the square, then graphing the circle. Now for number 20, it says use a graphing calculator to find the mean and the standard deviation, and to find the min x, q1, median q3, max x. So for this one, what I would suggest doing would be to first list these from smallest to lowest, or smallest to biggest. And I think I've already done that, except that one number should be 111. So it should be 111. And in order for me to make a box and whisker plot, I would have to be able to divide these into 4 equal groups. So I'm going to count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16 numbers, and 16 is divisible by 4. So each group, because I'm grouping them, is going to have 4 numbers in it. So each group is going to have 4 numbers in it. So I'm going to start. We have 102, 111, oops, that's a comma, and then 115, 136, that'll be group 1. Then group 2 would be 191, 222, 253, and 262. It's group number 2. Group number 3 would be 270, 300, 316, and 328. And my final group is going to be 347, 381, 401, and 491. Wow, just fits. So I'm going to start by finding the mean and the standard deviation using my calculator. So if you forget how to do that, you're going to start by clearing your calculator. So in your calculator, you're going to do second 7. That clears any memory from your calculator. If it says error, that means there is nothing there in the first place. And then you're just going to clear that error so you can start entering your variables. So I'm going to list every single one of my variables. So I'm going to start with 102. Oh, be careful. 102. Then I'm going to hit this button that's going to record it. And it says I've entered 1 variable. Then 111. Then 115. Then 136. 191. 222. 253. 262. 270. 300, 316, 328, 347, 381, 401, and 491. So altogether I have 16 variables plugged in. Now if you forget how to solve for the mean, you're going to use the second x squared button, and that tells me that the mean of all these numbers is 264.13 if I round to 2 decimal places. And then the standard deviation is second divide, which gives me 110.25. So that's 2 of my answers. Then it says, what's the min number? Well, the minimum number is going to be 102. So this is my min. My Q1 is going to be the median between these 2 groups. So the median between these 2 numbers right here. So to find that, I would do 136 plus 191 and then divide that by 2. So that says it's 163.5. The median is obviously the middle number between all of the boxes. So it'd be 262 plus 270 and then divide that by 2, which gives us 266. Then Q3 is going to be the median between these 2 groups, so 328 plus 347 divided by 2. That gives me 337.5, and then my max number is going to be this one right here, which is 491. And when you create your box and whisker plot, you're going to, you start with your minimum number. So this would be 102. And draw your line. The first line of your box. So this is your box. 266. That probably goes closer over here. So this would be Q1, which would be 163.5. So that's your Q1. This is your min. Your median is going to be 266, so you can say that's your median. Your Q3 is 337.5, which is your Q3. And the end of your whisker should be out here at 491, and that's your max number. So that's your box and your whisker plot. This is your mean and your standard deviation. This is how I found all of it. Basically using my calculator to just find the median in between all of those groups. Now moving on, we're looking at number 24. So for number 24, I see numbers outside of my logarithms, which are going to become exponents. So this would become, for number 24, this would be 3 to the power of log base 3 of 7 to the second power minus log base 3 of 2 to the third power plus log base 3 of 3 to the third power to the power of 4. So then if you see a minus sign between your logarithms, you are going to divide. So that would be 3 to the log 3 of 3 squared, or 7 squared, which is 49, over 2 cubed, which is 8. And then plus, and then when it's a parentheses raised to a power, you multiply those variables. So that would be log 3 of 3 to the 12th. So now you can cancel. So we could cancel the 3 and the log 3 here. I can also cancel the log 3 and the 3 here. So really what I'm left with is 49 over 8 plus 12. And you can make a common denominator here. So that would be 12 times 8 plus 49, and that would give me 145 over 8. Okay, so the laws of logarithms still apply when it's in the exponent, so that is something to know for those problems. Now for number 25, we're trying to find the area of this trapezoid. So what I'm going to do first is I'm going to draw a right triangle in this bottom corner. So I'm going to draw a right triangle right here, where this would be my height, this would be my hypotenuse. So for number 25, I'm going to use sine to solve for the height, because it's going to be the sine of 80 equals opposite, which is our height, over hypotenuse, which is 2. That means that my height is going to be equal to 2 times sine of 80. Now in my calculator, I'm going to do 2 times 80 sine equals. That would be approximately equal to 1.97, but I'm just going to leave that in my calculator so I can get as close to an exact answer as possible. So for the area of a trapezoid, it's going to be 1/2 the height times base 1 plus base 2, so 4 plus 5. So I'm just going to take this number, multiply that by 9, because 4 plus 5 is 9, so times 9, and then I'm going to divide it by 2, which means that my area is going to be equal to 8.86 meters squared. Now looking at number 26. So for number 26, it says to find the area in square centimeters of the segment bounded by an arc of measure 140 degrees in the chord, which joins the endpoints of the arc in a circle whose radius is 0.4 meters. So first thing that I'm going to do is my answer needs to be in square meters. So I'm going to convert in number 26, 0.4 meters to centimeters. So I know that there's 100 centimeters in 1 meter using my unit multipliers. So that means that my radius is actually going to be 40 centimeters. Now, the equation for area of the segment is as follows. X degrees over 360 times pi r squared minus the radius times a radius sine of x, which is base times height divided by 2. So that's really what it is. Base times height divided by 2. Now the x is just the degrees that they give us, which is 140. So 140 over 360 times pi times 40 squared minus 40 times 40 sine of 140 divided by 2. Now I'm just going to use my calculator for this. So 140 times pi times 40 squared divided by 360 is going to be 1954.768. For the second one, it's going to be 40 times 40 times 140 sine equals, then I'm going to divide that by 2. So that gives me 514.23. Now I'm going to subtract that, make that negative, and subtract it from the 1954.7688. And that would give me a result of 1,440.54 centimeters squared. So your label really does matter on this problem because it did convert from meters to centimeters. So you want to make sure that you actually did that. Okay, and that concludes number 26. Now moving on to number 27 and number 28. So for number 27, we have cotangent squared of 4 pi over 3 minus tangent squared of 7 pi over 6 minus secant cubed of negative pi over 3. So the 4 pi over 3, we need to make our snowflake chart for that. So this would be 1, 2, 3, and over 3 is always going to be a 60-degree triangle, starting at 0. Then over 6, going to make my snowflake chart there. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, starting at 0. And then over 3 again, so 1, 2, and 3, 1, 2, and 3. So first one, counting 4. So 1, 2, 3, 4. That puts me in quadrant 3. Again, I said anytime it's over 3, it's a 60-degree triangle. So this would be -1, negative root 3, and 2. And cotangent is adjacent over opposite. For 7 pi over 6, I'm going to count 1, 2, 3, 4, 5, 6, and 7. That's also in quadrant 3. Anytime it's over 6, it's a 30-degree triangle. So this would be negative root 3, -1, and 2. Tangent is opposite over adjacent. Last one, -1. So -1 means you're going to start counting in quadrant 4. So this would be my 1, my -1, which means it's a 60-degree triangle in quadrant 4. Adjacent will be 1, opposite negative root 3, hypotenuse 2. And secant is the inverse of cosine, so it's hypotenuse over adjacent. Okay, so now I'm going to evaluate. So cotangent squared. So adjacent over opposite would be 1 over root 3. Now it's square that. Tangent is opposite over adjacent. So again, 1 over root 3. And I'd have to square that as well. Then secant is hypotenuse over adjacent. So that would just be 2, and I would have to cube that. So 1 over root 3 squared would be 1/3. 1 over root 3 squared would be 1/3, and then minus 8. So my 1/3s are going to cancel, and I'm going to be left with -8 as my result. Now moving on to number 28. So for number 28, I have -420 degrees and +420 degrees. So -420 degrees, I'm going to add 360 to, because I need a degree less than 360. So -420 plus 360 would be -60. And then +420 minus 360 would be the same, but positive. So this first triangle is going to be in quadrant 4, a 60-degree triangle in quadrant 4. So 1, negative root 3, and 2. Sine is opposite over hypotenuse. Second one is going to be a 60-degree triangle in quadrant 1. So adjacent will be 1, opposite positive root 3, hypotenuse 2. And sine again is opposite over hypotenuse. Lastly is 270 degrees. So on my unit circle, 270 degrees faces down. That would be 0, -1, and cosine is equal to the x coordinate. So for this first one, opposite over hypotenuse would be -√3/2, but I would have to square that. The second one, opposite over hypotenuse, would be √3/2, but I would have to square that as well. And cosine of 270, well, cosine of 270 would actually be 0. So that would be 0, and I would square that as well. So √3/2 squared would actually turn into 3/4. √3/2 squared would also be 3/4, and 0 squared would just be 0. So my result is going to be 6/4, which is going to simplify to 3/2. And that would be your result for number 28. Now for 29, what we have is, it says write the quadratic equation with a lead coefficient of 1 whose roots are given. And this, we're going to start with the equation x minus root times x minus root is equal to 0. So x minus root times x minus root equals 0. So I'm actually going to plug in my roots, then I need to multiply this out. So when I plug in my roots, my 2 is going to change to -2. My √5i is going to change to -√5i. Second root, 2 is going to change to -2. -√5 changes to +√5i. And we're going to multiply this out. So x times x is going to give me x squared. X times -2 would be -2x. X times √5i would be √5ix. -2 times x would be -2x. -2 times -2 would be +4. -2 times √5i would be -2√5i. -√5i times x would be -√5ix. -√5i times -2 would be +2√5i. I'm running out of space, but -√5 times +√5 would be -5i squared, so -5, and then I squared is -1. So I know it's kind of hard to see because I had to squeeze that in there, but you should see at this point that my √5ix's should cancel and my -2√5i's will cancel. I can add my two x's together, so that would be x squared minus 4x. And then I have my +4, and this would actually turn into +5. So that would be +9 equals 0, and that would be my result. So remembering your formula is x minus root times x minus root. And then just plugging in your roots, changing the signs, and distributing. And then lastly, we're looking at number 30. So for number 30, it is kind of tricky because the first thing that we're going to do is we're going to plug in the f of x plus h into that equation, or the x plus h into that equation. That would make the equation 1 over, so if I plug in the x plus h into where the x is, it would be 2 times x plus h. Then the second part of the equation, I'm going to do minus, this is going to be all over 2h. The second part, I'm going to plug in x minus h into that equation, so that would be 1 over 2 times x minus h. Now what I need to do is I need to make a common denominator between those two. So I'm going to start by multiplying this first one by x minus h on top and bottom. And the second one I'm going to multiply by x plus h. So when I do that, I'm going to get x minus h minus x minus h all over 2 times x plus h times x minus h all over 2h. Now when I do that, the x's are going to cancel out. And then I have negative 2h. I'm going to multiply top and bottom by the reciprocal of 1 over 2h. And then I would get negative 2h over 2 times 2h times x plus h times x minus h. And then you should recognize that the 2 h's are going to cancel off the top and the bottom. Just want to confirm how they write their answer on this one. So 66. So what you should see now is that the 2h on top and bottom are going to cancel. So you are just left with negative 1 over 2 times x plus h times x minus h. And that concludes number 30. Okay, so those are your problems, your questions for lesson 16. Remember to be checking RunWeb. There is a surprise there on Monday, so please make sure you're checking that. Also, there's a test next week. So just a heads up and make sure you are checking RunWeb regularly because I will be adding things in there as extra credit or other things to help some of your guys' grades. So hope you guys all have a great weekend and remember to finish your lessons. Bye.